Hi everybody, I hope the sound works today. Uh, what we're going to do is we're going to use a graphics calculator to solve standard normal distribution problems. And so we're going to do the problems like find area to the left of z equals negative 1.27, or to the right, or in between, etc. So we're going to do problems like that. So let's take this over and I'll show you how to do this on a calculator. Okay, so what I have for you are a couple of displays, graphing calculator displays, of what we're going to call the normal CDF function. And the first thing I want to say to you is the C in CDF stands for cumulative. And if you'll remember back when we did cumulative distributions, we would add up the frequencies as we went. Well, the normal CDF is a cumulative distribution. So in the normal curve, it basically adds things all the way up on the left side of the value you're talking about. Now, and this is under the distribution window, which is right above the vars key. So second vars gets you distribution, number 2 is normal CDF. Now, when you get normal CDF on your screen, then it doesn't, this part here in the parentheses, it doesn't have that. But I wrote it down here so you can put it in your notes. These are the things you have to enter in. What you want to enter in is you want to enter the left bound, which is the smallest number you're looking at on the screen, the right bound, which would be the largest number, and then the mean and the standard deviation of the distribution you're looking at. So if you have all those written down, I'm going to actually show you how a problem looks in the normal CDF. And we can compare, and then we can do some problems we did yesterday. So what we have in front of you are 3 problems. Find the area to the left of z equals negative 2.14, area to the right of z equals negative 1.01, and the area between negative 1.14 and 2.01. And so in order to do these problems, I'm going to do exactly what I did before. I'm going to draw a picture of the situation. The means here, so negative 2.14 is there. All right, 2.14 negative. And I'm going to say that that means z is less than or equal to negative 2.14. And so then now find my answer. Area is, and without going to the table, I am now going to use the calculator. And so on the calculator, it would be normal CDF, and then that's followed by a parenthesis, and then I got to enter 4 numbers. Well, the last 2 numbers are the easiest. The mean and the standard deviation of the standard normal curve are 0 and 1. And so we've entered those, and we're good there. But the first 2 numbers, what's the right and the left bound? Well, when I look at my picture, if I come over and I look at my picture, what I see is in this picture, I see that the number furthest to the right in my picture is the negative 2.14. All right. And the number furthest to the left, well, it's basically negative infinity because it goes forever. So what I need to do is put a big number in there, like negative 10,000, something big, so that it will indicate that's my left bound. All right? And when I punch that out on the calculator, and so this is the real trick, is when you punch it on the calculator, you type 10,000 or excuse me, negative 10,000, comma, negative 2.14, comma, 0, comma 1. And when you do that, that gives us an area of 0.0162. 0.0162. All right, so the trick here is the right bound on area to the left is always the biggest number. The left bound is something a lot smaller that acts like infinity. Okay? All right. Okay, the last two problems are written in yellow for you. When you look at those two problems, you'll see I drew the pictures for each one, and then I set up the normal CDF in each case. All I want you to pay attention to is what the left and the right bounds are in each formula. When I do area to the right, the left bound is the smallest number, which is negative 1.01. The right bound is positive infinity, so I just need to put a large number in, say 10,000. Once I do this and type this into the calculator, the mean is 0 and the standard deviation is 1, then it's going to calculate my area. On the next one, the area between, the smallest number is negative 1.14 and the largest is 2.01. So those are my left bound and my right bound. Again, the mean and standard deviation are 0, 1, and that will give me the correct solution. So to review, if you have a picture where the area is to the left, then your left bound is negative infinity and your right bound is whatever that z value is for this spot. In that case, since your left bound is negative infinity, use a number like negative 10,000 or negative 90,000, some large negative number for your left and right bound. If you're doing area to the right, like this, then you'll have a z, and your right bound will be positive infinity. And for the same reason, the left bound is the z value, the right bound will then be use a large number like 10,000. And that should accomplish the same purpose. And then finally, when you want area in between, you're going to have a z here and a z here, area in between. In that case, your left bound is the smaller z and your right bound is the larger z. And if you do that, then the normal CDF function in your calculator works really nice. Left bound, right bound, and then you just put 0, 1 for the mean and the standard deviation of the standard normal curve. And so your homework tomorrow is 18 through 40, but I want you to do all the problems on the calculator and then compare your calculator answer to your answer that you did using the table. You should notice that there will be slight deviations because the table answers are only accurate to 4 decimal places, but the calculator answers take into account a much greater precision usually. Okay? So what do I want you to tell me about tomorrow? I want you to tell me about this statement. Okay, thanks a lot. Forget the announcement. To reiterate, the circled portion here is when you come to class, I want you to tell me what these things mean and what belongs where in the normal CDF function. Okay, thanks again, and I hope this sound